Arjun. I'm a PhD student at Georgia Tech, and this is joint work with Mira, Dontcheva, and Seth from Adobe Research, and Eytan Adar from the University of Michigan. So with our phones, smartwatches, and touch-enabled laptops, there's an increasing number of systems and devices that we interact with, which let us interact with them using multiple modalities, be it touch and speech or mouse and speech. Now, these systems are great because not only do they let us perform with them using traditional input modalities like mouse and touch that we used to, but they also let us use speech to interact with them in new and engaging ways that make the experience of working with the system much more easier. To set up the context a little further, let's take the example of a touch and speech-based multimodal photo editor. So I'll now play a quick video to give you a sense of what kind of things you can do with a system like this. So to add an effect, I can simply press on the image and say something like apply a sepia effect on the canvas, and the system's going to go ahead and apply that effect for me. Then to add a different filter on the girls in the image, I can point anywhere on the image once again and say apply a light morph effect on both the people, and the system automatically detects the two girls in the image and then applies a filter to them. Now to add new images to this canvas, I can say add an image to the canvas, then select from one of the images and drag it and place it exactly where I want. And then finally, to edit this newly added image, I can point on it and I can say apply a grayscale effect, and the system applies a grayscale effect just to that part of the entire canvas. Now, hopefully you'll agree with me when I say that this is a compelling new way of interacting with systems where I'm just simply pointing and saying what I want, and the system's doing the task of sort of figuring out what that means and how it needs to, what kind of operations it needs to perform to make those changes. Unfortunately, as a new user of such systems, you're most likely going to face two key challenges that prevent you from using speech in the way I just showed. The first of these is knowing what you can do, and the second challenge is knowing how you can tell the system to do what you want. Together, these two questions form the challenge of a lack of discoverability of natural language input. And as it turns out, this lack of discoverability is actually the second most common challenge that users of voice interfaces face today, and that's after speech recognition errors, which is the most prevalent one. To help users discover commands, systems today typically resort to solutions like command lists. So here you have Siri showing its list of available operations and example commands for each of them. This is not probably the best solution that you can have because navigating this list can get tedious, and the commands which are shown are generally very sort of generic, and they're not specific to the task that you might be interested in performing. So to overcome some of these challenges, our work seeks to explore an alternative way to support discovery of speech commands by suggesting contextually relevant commands. One related idea to this is actually that of tooltips. So tooltips are popular in desktop systems that we interact with today, and they've been evolving as sort of a mere description tool into more of a teaching aid in recent tools. For instance, here you can see some examples of how tooltips are now used to teach users about shortcuts, and in some systems like Photoshop, they even give a preview of a tool when you simply hover on it. But what does it really mean to have a tooltip for speech commands? Going back to our earlier example, say you have this multimodal image editor and you've loaded this picture in. Now, if you wanted to edit this image as a new user of this tool, one way that the system can help you learn and discover commands is something like this. So I simply point on the canvas and the system comes back to me with an example command that I can say to apply an effect on the image. Now, since it's showing speech commands when I point, it also automatically starts listening when it's showing the commands. So in this case, I actually like the idea of adding a blur filter, so I'm going to go ahead and repeat the command that I see. So I say something like apply a blur effect on the canvas, and the system adds the effect, blurring out the entire image. But having that blur on these girls in the image looks a little weird, so what I'm going to do is point on them individually to see what else I can say. So here when I point on the first girl in the image, the system comes back to me with a few more examples, and in this case, it shows me that I can issue commands to adjust the existing filter, add a new filter, remove the current blur filter which we've applied, or change the label that I'm going to refer to that girl with. Now, like I said, I don't quite like the blur where it is, so I'm going to go ahead and ask the system to remove that. So I can just follow the suggestion and say remove the blur effect. And looks like the video is paused. I'm sorry about that. Well, what's a speech presentation without some failures? So, yeah, so I can just say remove the blur effect. And I can do the same for the other girl, so I can point and I can say remove the blur effect. And the system is going to remove the effect from those two people in the image. Now, let's say I want to go and do what I did earlier, which is adding an image on the wall so I can make it look like the girls are actually looking at something. So for this, I can follow the regular interaction of sort of going and selecting a tool, or I can long press on that tool to see what I could have said instead of pressing on that. So in this case, the system's kind of giving me a command that I could use in the future. And so in this case, I'll just simply tap on that tool, take the image that I'm interested in, place it in front of these two girls, and then point on it again to see what new commands that I can learn here. So now as you see, the system's giving me new command suggestions, like adding a different effect or adding maybe a stroke or a border around this image. For now, I just want to add an effect to this image so that it blends in a little more with the yellow background. But over here, the system's giving me a suggestion of applying a morph effect, but what I really want to do is applying a sepia effect so that it blends in more with the yellow in the background. But since that text in blue is just an example, I don't need to follow that command as is, and instead I can replace the filter name and say something like, apply a sepia effect to this image, and the system goes ahead and does that, and that results in this image looking a lot more interesting and somehow how I want it to look. Now, while in this example, I showed how we can use tooltips as a way to suggest speech commands, tooltips are just one way in which we can suggest commands. Generally speaking, suggesting natural language commands is actually a fairly complex challenge and requires many considerations similar to other recommendation systems. For instance, we need to consider when we want to show the suggestions. So in the example that I was showing, the suggestions were popping up while I was interacting with the system, but an alternative could be that the commands show up with the first time when I load the tool. Additionally, we also need to consider what the suggestions actually consist of. So this includes thinking about points like how many commands should be suggested, how should their phrasings be varied so that the users can get a better sense of the system's understanding capability and so on. And finally, in addition to the when and the what, we also need to think about how the command should be shown. So for instance, in the example we were using tooltips, but you can imagine a system showing commands through either a pop-up window or a more traditional side panel. With these sort of different design considerations in mind, to test the general idea of suggesting contextual commands as a way to enhance discoverability, we implemented 3 interfaces that were used to present command suggestions. The first one we call the adaptive interface, and this is the one that I just presented where the suggestions are shown as tooltips when users point on different parts of the interface. We also implemented a second design that we call the embedded interface, where the basic idea was to augment the existing UI with speech commands. So here's what this interface looked like. I could tap and hold on the side panel to see commands corresponding to all the editing widgets. And I can do the same for the toolbar on the left to see how I can use different tools or invoke different tools through speech. Or to see commands for the entire canvas and the UI, I can long press on this button at the top. Or like I did in the example earlier, I can press and hold on individual items on the canvas, but instead of showing commands through tooltip, the system adds commands or augments the existing UI on the right side with command suggestions. So in this case, let's say I want to make the border of this image that I'm pointing at thicker, so I can follow the suggestion and say something like change the border size to 10, and this results in the system adding a thick border around the image. So while in the adaptive design, we use tooltips as a way to show speech commands, this embedded design avoids the occlusion that occurs from those tooltips and also creates a stronger mapping between speech and the existing graphical user interface. And finally, as a baseline design, we implemented what we call the exhaustive interface. The idea here is essentially similar to the command list that we saw earlier, but the difference is that commands get faded out or highlighted depending on the active state of the canvas. So let's see an example of how this works. So at any point during my session, I can tap this button at the top to get a list of different system operations and supported commands. And as you can see, commands towards the end are all faded out. And this is because those are not applicable to the current state of the canvas. So for instance, I haven't drawn any shapes on the canvas. So commands corresponding to adding a new shape or changing color of a shape do not make sense, so they get faded out. Now say while I'm looking through this, sorry about that. While I'm looking through this list, let's say I find one of the commands of adding a light sepia effect on all the people interesting. What I can just do is sort of get rid of this suggestion list and then go and tell the system to add a light sepia effect on all people, and that'll result in the system adding detecting all the people in the image and then just adding a filter to them. Now, while these 3 interfaces have different presentation strategies, A common theme is that they all need a way to decide which commands should be shown at different points in time. To do this, we developed a general framework that allowed us to go from system-generated templates to examples that could be shown to the user. At a very high level, given a list of command templates, we apply a set of heuristics to rank, filter, and parameterize these templates, which then result in a set of examples that can be presented to the user. You can find more details about this framework in the paper, but I'll give a quick example to give a sense of how things work. So say we take the example where I'm pointing on a rectangle and the system comes back to me with these 4 example commands. The way this works is as follows. So when I point on the rectangle, the system checks all available operations to see which ones apply in this case. To select and rank these operations, the system uses a combination of different features. First, it checks the type of operation that I'm pointing at and uses its internal model to determine which operations can apply. So since it's a shape object, the operation of adding an effect doesn't make sense because that's something that's specific to images. So that gets removed out. And now the system then reorders the remaining operations based on how many times they've been performed or suggested in the past in a way that the operations that have been performed or suggested the least number of times show up on top. So once it's ordered these operations, the system then considers the different possible phrasings for each of these operations. So say it takes the fill operation first and then looks at all possible templates for it. And based on these templates, the system then filters them out based on the type of input and the previous suggestions that it's made. So in this case, since I'm pointing on the rectangle when these suggestions are generated, the system's going to prefer phrasings that have didactic references like this or the word here, and select ones that it's shown the fewest number of times so that users get a more varied sense of what the system can do. So once it's selected a phrasing, it then populates that with an example value. And now while selecting this value, it's also conscious about what the active state of the object that is being pointed at is. So in other words, in this case, it'll pick any color for populating that example except blue because that's already the color of the rectangle. Together, this results in the suggested command color this green. And the system's now going to repeat the same for the remaining 3 operations. And together, this whole process results in the suggestion of the 4 commands that I showed at the start of the example. Now, once we had this framework running and the 3 interfaces to show the commands in different ways, we wanted to evaluate our approach through a user study. Now, one of the most challenging things about this user study was we wanted to see if the approach can help participants learn and discover natural language commands. But we couldn't do that if we did a standard lab study where we gave them training and sort of were there to influence them in some way or the other. So to emulate a somewhat in the wild experience, we conducted an online user study with 24 participants where the participants worked with the system on their personal devices without the presence of an external experimenter. We also provided minimal training, only telling participants about the basic user interface components and not giving them too many details about the speech commands. Participants were asked to perform a series of 3 image editing tasks, and the overall study took about 32 minutes to complete on average. Just to give a better sense of what the study task was, here's a sample task. So participants were given the image on the left, and they were asked to make it look as much as possible as the image on the right. From the 24 sessions that we had to discard 7 of them because we saw some sort of hardware failure or the participants just didn't follow the instructions. In terms of the overall usage of speech, we recorded a total of 834 commands from the 17 sessions, which is pretty high given that they received no formal training and this was an online experiment. Now, when we analyzed these commands, we obviously noticed a number of failures. And the most common type of errors were speech recognition or recording errors. And then there were other smaller groups of errors where participants said something that the system did not support. Now, these errors highlight a couple of things. The first point is that speech to text is still far from a solved problem. And the second one is that even with the suggestions, no matter how smart and well-placed they are, people are still going to try and guess commands every once in a while. But this failure also really presents an opportunity to provide suggestions at the right time. So since we saw these kinds of errors come up quite a bit during our pilot sessions in all of our systems, we also implemented a simple feedback mechanism that would work in the way that the system tries to give a suggestion when it thinks that the user is trying to perform something, but the command was wrong for it. And we noticed that participants really liked this feature and they would use it very often as an additional discovery tool. But even with all these different types of errors, participants generally agreed that the suggestions encouraged them to speak and help them learn how to talk to the system, validating our basic idea that the contextual command suggestions can aid discoverability. Another interesting observation that came up during the study was regarding the domain knowledge that was required to interpret these suggestions. So for example, when some participants saw a suggestion like apply a classic effect, they were unsure about what the effect of applying that classic filter would be. So one interesting direction to explore going forward would be something like considering these example commands as interactive widgets that people can maybe touch on or hover upon to see potential outcomes of issuing that command. And speaking of future work, the framework that I showed today to use this, to suggest the commands is just a boilerplate and can really be used in any multimodal interface. So as part of our ongoing work, we're now applying the framework to other application domains such as data visualization, and also exploring how we can support other types of multimodal commands such as those that combine gestures and speech. So just to summarize, I hope that I've been able to convince you of two things with this talk. First, that contextual command suggestions can aid discoverability and encourage natural language interaction. And second, that we can leverage direct manipulation as a way to teach natural language interaction. With that being said, I'd be happy to take any questions. Thank you.
Yeah, okay, yeah, we have questions already.
Thanks. So, yes. So, all the examples you've shown are ways where I can use language in order to do things that correspond to GUI options. Mm-hmm. Are there cases where the language enables more than what the GUI affords?
I think yes. And a very simple example of that is, let's say, combining different operations on the GUI itself, right? So you create a shape using a tool, and then you change its color, and then you change its size. These are three different operations, but language can let you combine them all into one step. So that is a different case, and the way we handle that is by in two ways. So in the exhaustive interface, which is the one on the right side, you would see some variations of these commands which are sort of more language heavy available there. And on the other interfaces, one of the metrics that we have, which I didn't talk about today, is complexity. So as users incrementally work with the system, and let's say you issue the command to add a filter and then change the filter, the system's next going to start telling you how to combine these commands. So the suggestions kind of improve as you use the tool. So to begin with, it's going to leverage the existing UI so that you get a better sense of how things work today and how you're going to replace that with speech. And over time, it helps you learn more complex commands. Does that answer your question? Okay.
Do we have any other questions? We still have a few minutes left. Yeah.
Hi, nice talk. Not really a question, I think it's a comment. So when you're showing tooltips about possible actions, mm-hmm. if the action is kind of deterministic, then I think you can just have numbering so that user can just pick a number mm-hmm. that operates over the full NLP. Right.
So one of the things was and there's a lot we can do, for instance, like just treating each of those suggestions as interactive widgets brings up like another layer of complexity where you can tap on it and lead to almost like a tree structure. But the reason why we didn't want to do something like that was we wanted people to actually learn how to talk to the system. And that was the goal that drove this, rather than kind of making it easier for them to select from a list of options that's available. So by showing all the commands and expecting them to actually say those, we were hoping that people would learn how to speak as opposed to just use it as a shortcut.
So are you saying eventually you want a system where you can just speak to a system?
That's the ideal goal of sort of any natural language-based system, where people can just say whatever they want and the system's doing it. So this is a way to kind of push them towards that and teach them how to do it, leveraging their existing knowledge of the tool.
Any other questions? Yeah.
Hello. First off, fantastic presentation. And my question for you is, during your observations with the data that you got from your user studies, did you find any differences in how your participants reacted to these different adaptation techniques? More of like their preference of them, or did you have some users that absolutely hated them, some users who liked them more?
Right.
That's about it.
So in this particular case, we did a between subjects, so we don't have data on like sort of comparison between them. But when we asked them two specific questions, one of them of did the systems or the suggestions, do they help them learn how to talk, and do they encourage them to talk? We saw the adaptive one was one where people liked it the most, but that's also partially because we were very smart about how the suggestions were shown. On the other hand, the embedded one and the exhaustive one had sort of comparable moderate sort of ratings. But people also spoke the most number of commands in the embedded design, which probably means that because they're already used to the UI sort of model and the system augments the existing UI with commands, they see, oh, that's what I can say, and it shows a wide range of different commands that you can say. So that's probably, the embedded one is encouraging them to speak more, whereas the adaptive one gives them just what they want at the right time.
Okay. So the embedded one is like more contextually relevant to what they're doing at that?
The adaptive one is.
Oh, the
The embedded one is just more breadth oriented, but it's within the existing UI, so it lets them leverage their knowledge
Okay.
better.
All right, thank you.
All right, we maybe have time for one more question.
So the question is, because you're using pointing and a natural language interface, do you have an assessment for how the ambiguity of the natural language interface was improved or degraded by adding the pointing?
So we didn't test that specifically, but our hope is that this kind of a technique where you're pointing on things and suggestions only for that aspect of what you're pointing on come up would help reduce ambiguity. Because in an ideal world, if somebody just follows the suggestions, the system's never going to fail, and there's going to be no ambiguity because every suggestion maps to exactly one operation. So we didn't study that specifically, but we think that this can reduce the ambiguity that occurs in natural language because you're more clear about what you want the language command to get applied to. Does that answer your question?
Great. Okay, let's thank our speaker one more